Welcome to the EasyPower webinar for this week on short circuit calculations using EasyPower. My name's Dave Castor, electrical engineer. So we spent a lot of time in the last few years worrying about arc flash calculations, and the short circuit calcs are the first step of that. And I thought today we'd step back and look at the additional features and capabilities in the program for doing short circuit calculations specifically. So we're going to go through kind of informally these topics here, and first we'll just walk through the process of doing short circuit calculations in EasyPower and how the program works and interacts with you. Next we'll look at what results get displayed on your one-line diagram and your options for controlling that. We'll talk about the types of faults you can do in the program. And we'll look at the text reports, options for that, and how you can export the text reports into Word or Excel. I'll look at other options within the program for controlling how the short circuit calculations are done. And we'll look in some detail about how to control the buses that are faulted when you run the short circuit calculations. It's not necessary to fault every bus in EasyPower when you run a short circuit calculation. We give you a great deal of control over how that happens. We're going to look at the SmartBreaker feature, which allows you to open and close breakers and switches while you're in short circuit focus, to look at the impact of opening and closing breakers on the short circuit calcs. We'll look at another feature that's extremely useful called just remote voltage and current. For any particular bus, you can look at the voltages and currents throughout the system for a fault on that particular bus. And we'll talk briefly at the end about the capability we have called fault and store, which allows you to display short circuit results in your panel schedules and MCC schedules. As far as the mechanics of the webinar, if you have questions regarding the technical content, you can submit those, just type them in, and we may have time at the end to deal with those. If not, we'll definitely get back to you by email with an answer to those questions. Okay, so that's what we're going to do, and we'll just going to go right into the program here. So this is EasyPower 9.8, and I've just got, let me zoom out here, I've just got a sample file that I kind of threw together here for purposes of the webinar. I'm going to turn off this equipment palette here just to give me a little more room on my screen. Let's just close that. So when you first start up the program, obviously you're in database edit, and that's how you're going to build your model. When you get to the point of wanting to do a short circuit analysis, you're going to switch from database edit to short circuit focus, and that's this lightning bolt. And so when you click on this, it doesn't actually do the short circuit calculations. It simply does some validation of your data. So any of those little boxes that have the red dots next to them, or red boxes in your MCC schedules and those kind of things, those all need to be filled in, or you're going to get an error message and a list of things that are missing when you go into short circuit. But what happens now when I go into short circuit is the program does that data check. If you don't see any error messages pop up, that means it found data where it was looking for data. It does turn off some of the annotation, the information, specifics about the breakers and that kind of thing. The data fields get turned off, and that's simply just to make room for the short circuit data that we're going to display here on the one line. Okay, but like I said, when you first go into short circuit, no calculations have been done in terms of short circuit calcs. Okay, that's still to come. What does happen when you go into short circuit is my palette changes up here. I'm now in short circuit focus, so my options up here in the equipment, in the palette, in the toolbar up here change in the ribbon. So these are the commands for initiating the faults. This controls what type of fault and what's displayed. And the rest of these are related to short circuit options, options for reports, and so forth. Okay. All right, so the basic process is you go up here to the lightning bolt and you click on fault buses. Now by default, when you first start going to short circuit, it's going to be defaulted to the half cycle or momentary fault network and three-phase faults. That's what these icons are indicating. And that's the most common short circuit that you're going to be dealing with. And that's generally the worst case in terms of the absolute magnitude of the fault. So the process is to simply click on this bus or this icon here, and then it runs the short circuit calculations. So what happened there was I did not have anything selected in my one line. And so when I click on this, it's going to fault every bus and give me the results for each bus. Now you have to keep in mind that the program faults each bus sequentially. So it's faulting each bus one at a time. It doesn't, there's no way to fault every bus all at once. It's faulting each bus one at a time. It just does it very quickly. So it seems simultaneous, but in fact it's faulting each bus individually. So just a typical result that we get on the one line for the short circuit calculations. This value is the total bus fault current in kiloamps. So 20.99 kiloamps or 20,990 amps. These values here are the contributions from each source. Again, this is in kiloamps. So these are the motor contributions coming back up depending on how the motors are defined. So 520 amps, 1300 amps, 2340 amps, and so forth, and 16,830 amps coming down from a utility source. Okay, so the sum of all these is going to equal the total bus fault current. Okay, keep in mind though that this is a phasor summation. Each one of these currents has a magnitude and a phase angle associated with it based on the source's X over R ratio. So if you just summed all these up directly, arithmetically, it's not going to be exactly 20.99. But if you went back and looked at the phase angles of each one of these currents and summed them up, you would get this value. Okay, so that's what's displayed for each bus fault. If I come over here, I have a similar value here. So in EasyPower, if I have a motor control center or a panel, when I run the short circuit calculations, it's treated like a bus, basically, okay? So I get a total bus fault current and I get the contribution. Now the difference here is I have 23,000 total bus fault current. I have 21,000 coming down. So what's not shown here on the one line are the motor contributions from the motors that are defined inside of the motor control center. Okay, so that's why this total bus fault current is greater than the source value coming down. Okay, so that is the basic display by using the default settings that you get in EasyPower. Okay, so let's take a look at some of the options in terms of what gets displayed on the one line. And to do that, I'm going to go to short circuit options, and I'm going to get this dialog. And over here we have the different views, the different screens here you can look at under short circuit options. And we're going to be looking right now at one line output. You have some options here for the display. If you want to see the units, if you want to see kiloamps out here on every single value of current, you can turn this on here. Okay. If you don't want to see the CT and relay symbols, you can uncheck this box. It's just a way to clean up the one line a little bit more. And also, if you don't want to see the branch flows, these are the branch flows here, you can turn those off. And we'll come back and talk about remote voltage and current here in a little bit. You can control the number of decimal places that are shown by changing this. Right now it's set at 2. That can be changed. And more importantly, what we're looking at are symmetrical amps in kiloamps, okay? So by default, these are the symmetrical values, the symmetrical RMS current. So this neglects any asymmetrical current or DC offset, okay? Now, I have options there for changing this. I can look at symmetrical or asymmetrical, or I can look at max symmetrical and max asymmetrical, okay? We'll switch that in a second here. If you want to see in per unit, you can change this, or you can look at it at MVA, which is not really common anymore, but we do give you that option. Okay, so let's see what it looks like. I'm going to switch it from symmetrical to max symmetrical and max asymmetrical. So anytime you change an option here while you're in short circuit and you say OK, what's going to happen is the program's going to apply this change, and then it's going to rerun whatever the last short circuit calculation that you did. In our case, I had faulted every bus. So when I say OK, it's going to make this change, and then it's going to automatically rerun that fault all buses, okay? So we can see here what changed. I still have this value, which is the symmetrical current, maximum half-cycle fault current, right? But in addition, now I see this 67.96 kiloamps in parentheses. The parentheses indicate that this is an asymmetrical value. So this is the peak asymmetrical current. It's still an RMS value, but this reflects the maximum possible or maximum expected asymmetrical current. And that's based on the X over R ratio of the system, looking back into the system from this fault point here of this bus, okay? So the higher the X over R ratio, the greater this asymmetrical current will be. This has an impact on our circuit breaker short circuit ratings, also perhaps on our settings of our instantaneous strips and those sorts of things that would respond to this asymmetrical current. So what the program does is calculate the symmetrical current, and then based on the X over R ratio, it calculates the maximum asymmetrical current. Now keep in mind, this doesn't happen every time, right? The asymmetrical current is dependent on the X over R ratio, but for any particular fault, it's dependent on the voltage phase angle when the fault occurs. So this is a worst case value, assuming the fault occurs at voltage 0 degrees, okay? But that's normally what we have to worry about because we don't get to pick when the fault happens. So we're going to look at worst case here. So all of these values now in parentheses are, this is an asymmetrical current, okay? Okay, so let's go back to short circuit options. And let me change this back to symmetrical. I mentioned that these values that the program's computing are phasors. There's a magnitude and a phase angle. If you want to see that displayed in the one line, you can do that. So by default, we only see the magnitude of the currents. If I want to see the magnitude and the angle, I select this and I say OK. So now for every value of current, I see a phase angle associated with that in degrees. So 51,800 amps at minus 80.3 degrees, and that's referenced back to your source, which is assumed to be 0 degrees, your utility source. So this is the phase angle that's displayed. It gets to take up a lot of real estate, so generally we don't display it, but that value is available, if you, for some reason, want to look at these phase angles. You can also view them as the real the real and imaginary, as opposed to the polar form here. Okay, so that's an option for what gets displayed. Let's talk a little bit about the different types of faults you can run and the control you have as far as what gets displayed here on the one line as a basis of that. So by default, when we run our short circuit calcs, we're looking at A phase only. That's what this A is highlighted here. So this value is A phase. Now this is a three-phase fault, so the other two values are the same, right? It's a balanced fault. But EasyPower allows you to display three different quantities here while you're in short circuit. Maximum of 3, and you have some control over what that is depending on what you're wanting to look at. I can look at the phase currents by clicking on this. Okay, so these A, B, and C, A, B, and C. Okay, so it's a three-phase fault, so that doesn't really show you too much new information. Okay. We also have the option of looking at the sequence currents. The program uses a symmetrical component method to calculate the short circuit currents both for the balanced and unbalanced faults. So these values are available if you want to display those. If you're not familiar with symmetrical components, you don't really have to worry about it, but if you do want to see those, they can be displayed in lieu of the phase quantities. So if I click on plus, minus, and 0 sequence, now instead of the phasor quantity, the phase quantities, I see the sequence currents. In this case, it's all positive sequence, and there is no negative or 0 sequence because it's a balanced fault. I have three-phase fault. But that is an option. Okay. Now, if I want to go back to A phase, and it's going to turn those off automatically because I'm limited to 3 different values of current. Okay. The other option we have that we can change here is the type of fault that's run. So by default, we have a 3-phase fault. That's what you use for determining your breaker duties. That's the starting point, at least. Also, your arc flash calcs, that's the starting point for determining your arcing current, is the 3-phase fault. But we also allow you to calculate line to ground, double line to ground, and line to line. Okay. So if I switch this from 3-phase to line to ground, it simply reran the last calc I did, and now I'm looking at, these are line to ground faults. Okay. So again, I'm still looking at A phase, but these are for ground faults. If I add the other phases in, you can see that the currents are different. So I have a line to ground fault on phase A. So effectively, I have no current at the fault point for phase B and phase C. Now note that when you have a delta Y transformer here and you have sources other than the utility source, that you can have current in the other phases for some of the contributions. Those will balance out and you'll end up with 0 at the fault point. Okay, so if I were to change this to double line to ground, again, it's just going to rerun that. It's going to give me it's going to have B and C phase to ground, and finally line to line. Okay, so I can display any of these values, types of faults, by changing this selection here. If we put it back to line to ground, you can also, again, if we look at the sequence currents for a line to ground fault, these are all the same. That's the typical classic analysis of symmetrical components. Single line to ground fault, positive, negative, and 0 sequence are the same. You can, instead of the straight 0 sequence current, you can look at 3 times. This is closely related to the actual ground current. Okay, so this 5399 is essentially going to be the ground fault current, which is the sum of the 3 zero sequence currents. So if you're trying to sort out why your display looks odd, then make sure you note what you're set at here on your display. Okay. All right, so I put this back to A-phase and 3-phase faults. The next thing I want to talk about are the 3 different fault networks that we have. So this is half cycle momentary, which is the default. This is 5 cycle, or interrupting. And this is 30 cycle. So what that means is that we're taking a snapshot of what the fault current will be at different times during the life of the fault. The fault current tends to decay over time because things like motor contributions will decrease or drop out entirely. So this will reflect that. So again, I can switch this. I can look at all 3 of these at the same time. If I'm only looking at one phase current, then I can look at all 3. So this is the half cycle, this is the fault current after 5 cycles, and this is the fault current after 30 cycles. And you can see what's happening here. So the half cycle, I have the maximum motor contribution. After 5 cycles, it has decreased, and then by 30 cycles, it's 0. Okay. Induction motors contribute fault currents initially, but that contribution dies off quite quickly. So that's the meaning of the different fault networks. This becomes important. The half cycle and 5 cycle are important for medium voltage breaker calculations and some relaying applications, and the 30 cycle is mainly used for relaying of medium voltage, high voltage systems where you might have relays that are fairly slow, backup overcurrent protection, when you want to see what the current's like after a certain amount of time. All right, I should note that when you have your fault currents displayed on your one line here, if I were to print out this one line right now or do a copy and paste to paste this into a Word document or something else, then the fault values will show up in that document. Right? It'll look just like you see here. So that's the basics of what you see on the screen, how you can control what gets displayed. We talked about the types of faults and how you can control that. Let's talk for a little bit about the text reports. If I want to print out a short circuit report, how do I do that? Okay, so we have a button up here that says short circuit text reports, and you can actually get to it from the short circuit options. If I click on short circuit options, there's an option that says text output, which looks like this. If I click on short circuit reports up here directly in the ribbon, it takes me directly to the same spot. So just 2 different ways of getting to the same place. So these are the different reports that the program can produce. And in addition to the straight short circuit reports, we also have the equipment duty report. Now, if you're concerned about your circuit breaker ratings or fuse ratings, this is what you're really going to want to look at. I'm not going to spend a lot of time on equipment duty in this webinar, but that's definitely a key feature of the program, and you may want to, there are some past ones we've done to talk about this, but keep in mind that if you're doing an arc flash study, you're definitely going to want to look at your equipment duty, make sure all your breakers are adequately rated, and this is how you get there. This is the equipment duty report. Let's go back now and look at the short circuit reports though. So here's my half cycle, here's the 5 cycle, and here is the 30 cycle, okay. Now under the half cycle and 5 cycle, we have some options about what's included. So if I click on, say, create half cycle, then I can choose to include fuse duties, molded case circuit breaker duties is checked by default, I think, and low voltage power circuit breakers are checked. This is related to the fact that these breakers and these devices are tested at different X/R ratios. So their duties, the current that you need to use to check their duties varies depending on how the devices were rated and tested. So So we'll leave that on. So we'll take a look at the half cycle and 5 cycle. We have some options as well on the level of detail that you see. So we have a simple, a medium, and a detailed. And in the detailed, you can actually make it more detailed and include the branch circuit X over R ratios if you're trying to figure out why those angles are what they are. And we have a symmetrical component format. If you want to see the sequence currents and values, then you can use this. And we have an option for, we have a GE format that duplicates the format that GE had an old time-sharing system that ran on their computer many years ago, and so we can reproduce that format. It's probably more of a legacy thing at this point. So let's just take a quick look. I'm going to change this back to medium. I'm going to let you guys, you can explore what the differences are in these formats. I run these short circuit reports. In EasyPower, the reports, all reports are always created minimized in a separate window. So these are little windows that are created and they're minimized. For the short circuit reports, the program reduces the size of the one line in order to show me these minimized reports. That's why the one line shrank down and got smaller, okay? So you would get that back to the full size by clicking on this. Most of the other reports in EasyPower don't have this behavior. They don't shrink the one line down like the short circuit reports still do. If this behavior is really annoying to you, then there is a fix. You can change this in the registry settings, but you just email tech support and they can tell you how to do that. So this is sometimes annoying if you're constantly having to go back and increase the size, but it's been this way for a long time, and people that have used the program are used to the behavior, so I think we're reluctant just to take it out. But anyway, these are the different reports that we created here. We also have in the ribbon, we always have this window button. So if I drop that down, it shows me all of the reports here, all the windows that are open. So it's probably easier to pick them from the list than it is to try to figure out which one of those is which. So if I want to look at the high voltage momentary report, which is the half cycle, I just click on this. It's going to open this window, okay? So this is the high voltage momentary report. We separate out high voltage and low voltage, and per the NEC, that's anything over 1,000 volts is high voltage. So the display is a little bit different because of the way the breakers are rated at medium and high voltage is different, so we calculate things just slightly differently. But this is the typical short circuit report that you're going to see. So it's done by bus. Again, we're faulting by bus. So if you want to see a short circuit result somewhere in your system, there has to be an EasyPower bus there, or a motor control center, or a panel, or an automatic transfer switch. Those devices are treated like buses. If you just have a motor down there connected to a bus, you're not going to get a short circuit result at the motor. You would have to put a bus down there to see the short circuit value, because we're calculating this at the buses, at the nodes of our network. Okay. So it's listed alphabetically by bus. So we have symmetrical amps, the X over R ratio, and the multiplying factor, then asymmetrical amps, and then finally 2.6 times symmetrical. This value is used in some circuit breaker ratings. This essentially is a peak value, crest value, worst case. So that's what's displayed. If I were to minimize this, I could look at a low voltage momentary, and it looks very similar. I have a little more information because of the boxes I checked. So for each bus, I have the symmetrical amps, X over R ratio, and then the asymmetrical amps. And then over here we have, based on the X over R ratio, at the fault point, these are the adjusted duty amps for the different types of devices. These numbers are different. All right, so maybe we lost audio there for a second. Hopefully you can still hear me. These values are different because these devices are tested at different X over R ratios. So these values have been adjusted to match the tested value, okay? The tested X over R ratio. If you're actually concerned about specific breaker ratings on the bus, you're going to get better results, more accurate results if you run the equipment duty report rather than using this. This is conservative because it's using the total bus fault current. But remember, not all the devices on your bus see that total bus fault current. Okay, so that's what the reports look like. All of these reports, you can print these directly from EasyPower. You can also export these to Word or Excel. So up here there should be a button that says Word Export. And if you have a really old version of Word, you can use this, or you can do it to Excel. So if I click on Word, what's going to happen, hopefully, is that it's going to convert this output. This is essentially now a Word file, and this is a Word table. So the report is now in this format in Microsoft Word. It's just a table. So it's pretty easy to get your short circuit reports directly into your Word file or Excel file by using that export function. Okay, so that's what the reports look like. If I reduce this, typically you're going to be most concerned with the half cycle, high voltage, low voltage. If you have medium voltage breakers, you're going to be concerned with the 5 cycle, perhaps. The 30 cycle is really going to be only for relaying. We produce a low voltage interrupting report. It doesn't really have a lot of application in terms of breaker ratings or anything like that, but you can produce this is basically the fault current after 5 cycles, if you're interested in that for some reason. Okay. So if I look at the high voltage interrupting report, it's similar to the momentary reports listed by bus, again alphabetically, but now we look at the different factors that influence the medium voltage breaker ratings, and this format is basically per the ANSI standards. So I have the breaker rating type, interrupting time, parting cycles, and whatever adjustment factor has to be applied to give me the breaker duty amps. So again, if you're actually concerned about the breaker ratings, you're better off to run the equipment duty report. So I think that I'll leave it there for the reports. Like I say, the equipment duty report's going to be important, but that's probably more than we're going to be able to cover today. So I would encourage you to do some review on that. It's pretty straightforward. You can also review the some equipment duty information on the one line. It's going to show up as percentages, and if something's underrated, it turns red. But you may want to refer back to some previous webinars we've done on the equipment duty report. Okay, let's look briefly at some other options that we have in the short circuit calculations. So if I go back to short circuit options, I'm going to go up here to this top row that says control. All right, so this fault type is essentially the same as these boxes here. So that's the same. But down here, excuse me, down here we have some other options to apply, and mainly the fault all filters. So when I do a fault all, if I don't have any other filtering criteria applied, it faults every bus, but I can control that to some extent. So I can specify a voltage range that I want to fault. So if I were to set this, say, minimum kV at 4.5 and the maximum at 0.5. Then I come back and do a fault all. I only get the 480 volt buses basically, right? It has to be a bus within that voltage range. So if I'm trying to restrict my faults to a particular voltage range, I can do that here. Right now we go from 0 to 1500 kV. So this is by default, we get everything. Okay, so you can filter your fault results by voltage range. This also would apply to your arc flash calculations. Okay. Other thing I should point out is when you change the short circuit options in a scenario, that is stored as part of the scenario. So the scenario manager respects changes made to short circuit options inside the scenario. So you can have different scenarios with different short circuit options, different arc flash options set, and that is tracked in the scenario manager. Okay, the other way you can filter the fault all is by area and zone. And EasyPower allows you to set an area and a zone for every bus, MCC, and panel. So a zone is kind of a sub area. So these are numbers, but basically you can break your system down into buildings or floors or units or however you think about it, and then you can report back just on that particular area and or zone just by setting these here. With these set at 0, you're going to get every area and every zone as the default. Okay. Driving point voltage is basically the source voltage when the fault occurs. So this is in per unit. So right now it's set at 100%. If your utility voltage runs consistently high or low, that affects your short circuit calcs. So you might want to set this up. If you're running 2 or 3% high, if you increase this, you will get more fault current. This does change your answer, changes your arc flash. So you may need to adjust that, do different scenarios for different voltage levels, and you can do that here. The equipment duty threshold, this is for when you get basically get a warning when you get within 10% of the breaker ratings when you run your equipment duty reports. Voltage sensitivity threshold, we'll talk about that in a minute when we do the remote voltage and current. Okay, so those are the other options you have for short circuits. All right, so far I've just been faulting every bus, and we give you a lot of other options. We mentioned the filtering by voltage level, area, and zone. You can also do it by selection. Now, I'll show you also, we have a function, if you want to clear you don't have to do this, but if you want to clear the results between runs, if I right click out here on the white space, down there's a clear, and that's just going to clear your results and kind of reset everything. It's not necessary to do that to rerun the fault, but it does clear your results. So if I want to just fault one particular bus, remember the program always calculates this per bus, so that's what makes this work. I can just double click on this bus. I'm going to turn off these reports so I don't have to keep changing the. So I just double clicked on that and it faulted that one bus. Okay. I can do the same thing for an MCC because we treat those like buses. Okay. So this is a real quick way to do a short circuit calc just for one particular bus. Okay. So that's the double click. I can also do a selection. So if I were to drag a rectangle around these two buses here, whatever's in my selection area, whatever buses are in there now when I go to fault buses, it's only going to fault the buses within my selection area. Okay. So that's the other way we can limit what you're faulting. So with nothing selected, you do the faults every bus. If I double click on a bus, I fault that one bus. Or if I have a selection made within my one line and I do a fault up here, it's going to fault only the buses within that selection. Okay, I want to talk a minute about the SmartBreaker capability. So I've got this double-ended substation here. I've got the tiebreaker closed. Both the mains are closed, so I get a lot of fault current on each bus. If I want to see what happens if I, say, open the tiebreaker, if I'm in short circuit, I simply double-click on this, on the breaker itself. It's going to open the breaker and rerun the last fault calculation. Okay. If I click on it again, it's going to close it. This works for any breaker or any switch. Okay. All right, so that's SmartBreaker. Now, when you've done this and you go back to database, it's going to get this message about temporary changes have been made to your system. So if you say yes here, it's going to save to your database the status of these breaker positions that you had in short circuit. If I say no, it's going to revert back to what they were before you went into short circuit. So you always got to keep that in mind here. Anytime you change the breaker status, you're going to get this little box when you go back to database. Okay, so that's SmartBreaker. And again, that works on any breaker or combination of breakers. Okay, so going to talk a little bit about a feature that is find it extremely useful, and that's called remote voltage and current. If I fault one particular bus, I'm going to come down here and fault this MCC 7A. Again, this is treated just like a bus. So here's my fault current. And let's say I want to know how much current is going through this relay. Okay, I can simply right-click on this bus, and instead of fault bus, I go down to remote bus voltage and current. And now, if you look closely, if I move this other stuff out of the way, you can see it's 1.18 kiloamps, 1,180 amps flowing through this CT, and my voltage at this bus is 0.94 per unit or 94%. So this only works when I have one single bus faulted, right? But for any other location in the system, if I right-click on it, I can say remote bus VNI. It'll show me what the voltage is. So if you remember in the short circuit options, we had that voltage sensitivity. You can run a report that says how many buses are below whatever value you set there for this particular fault. Okay, that's the voltage sensitivity report. We also have a button up here now that can do the same thing. Okay, so remember, it only works for one particular fault. Okay, so that's what we call remote VNI, voltage and current. So it's really helpful if you're doing relay coordination or you want to see, what's going on in the system in terms of voltage dip. So you can see this switchgear bus here is down to 50% voltage for this fault. Okay, so one last thing we'll go over here is a feature we added. We had customers request the ability to display short circuit currents and arc flash results in their panel schedules when they print the panel schedules and the MCC schedules. So we've added this capability called fault and store, and we kind of hide it, but it's here. So we go to fault buses. There's a little triangle there. You can drop this down. There's a few options, and down under the advanced, there's a fault and store symmetrical KA and fault and store arc flash. So let's take a look. I think I've probably already run this. What the program does then is it runs the fault analysis, calculates the fault current for that bus, and then it actually stores that value in the database. and then you can it'll put that value in your panel schedule, and it is stored in the database. Okay, so if I do that, really it looks the same on the screen. But now if I go back to database, and you got to say save here, I believe. I got to say yes. And if from database, if I double click on the panel, get rid of that, and go to summary, then it's going to give me the short circuit current here in the panel schedule, or I have the capability of putting it in the panel schedule if I want it. Okay, and you can do the same thing with arc flash. Okay. Now, we generally don't like storing the results because the issue is if I make a change to the system after I do this, these results do not automatically update, right? You have to go back and rerun the short circuit count. So as long as you're aware of that, then this will work. But just keep in mind, if you want to make sure you have the latest values here, you need to rerun, after you've modified your system, you're going to want to rerun those calculations. But that is the fault and store. So you do it for symmetrical kiloamps, or you do it for arc flash. Okay. All right, so the last thing, we got a couple minutes, is the line in fault. You may have seen that, this guy here. What that really is probably not something you're going to use a lot, but if I come up here, and the way this works is I'm going to select a particular circuit breaker, and if I do a line in fault now, it essentially gives me the fault current coming back up this way as if this line here was open. And I'm not sure why I have 0 amps, but that's the meaning of the line in fault. It only works for one single breaker. Let me go back to database here for a second. I think I was only faulting one bus there maybe. So that should be giving a result as if I had a short circuit and this connection here was lost and all the current was coming back up this way. I've got some setting that's not giving them a result here. These are zeros. It shouldn't be. But that's the meaning of the line in fault. Okay. Let me try this. Oh, okay. So I'm not sure why I'm not getting a result there. It's not something I use a lot, but that's how it should work. And I'll see if I can figure out why I'm not getting a result there. But that's the significance of the line in fault. Okay, so that's pretty much what we're going to go through for the short circuit calcs in EasyPower. Just keep in mind the ability to fault individual buses or selections. You don't have to fault the entire system every time. And the remote voltage and current, and also the ability to modify what you see in the results. Okay, so for those of you that had questions, we will definitely get back to you by email if you have specific questions that came up during the presentation. But otherwise, I'd like to thank you guys for sitting in today, and hopefully you'll come back again for future webinars. And thanks for sitting in, and have the rest of your day be good. Thanks. Bye-bye.